Morning. So one of the important topics in mechanics is the topic of tension. Many students are confused, when you see a numerical that has tension and weight. So this conceptual discussion will help you understand how, in a massless, inextensible string, the tension is transmitted, and hopefully this will bring to rest many doubts that students have in terms of mechanics, especially tension. So I'm going to do a small conceptual discussion and a sample of free body diagram for a massless inextensible string. Just concentrate on that and try and learn how does the force tension acts as a medium of transmission of force through the string. Thank you. All right, so let's discuss the inextensible massless string with which mass is connected, and you're holding this with the help of the string. Okay, so this is your hand, and that's your string, and that's your mass. Okay, let's draw the free body diagrams. Let's draw the free body diagram of hand first. So if you look into the hand, these are your fingers and you're holding the massless string. The massless string, applies a force on the hand, string on hand, and as a reaction, the hand applies an upward force. So this is called hand on the string. So this is free body diagram number one. The second is when you pick up the interaction at this place. Okay. Now draw the mass and the string. So that's your string. Look into the interaction. So the string pulls the mass upward. So this is the force applied by the string on the weight, and then the weight brings down the string. Okay, so that's okay, so this is as a reaction you draw a force downward, and this is the force being applied by the weight on the string. So far what we have considered is the action-reaction force here and the action-reaction force here. Now let's talk about the last part of it, which is the mass. Okay, the mass M, which is, so if you look into this mass, it is being pulled down by the gravity. Okay. Now, if you study this whole thing, you apply the Newton's second law at this point, and then apply the Newton's second law at this point. So these are the two places you apply this, and you know that the mass is inextensible, so the action produced will be zero, because when you apply your Newton's second law, mass into acceleration will come out to be zero. So your acceleration is zero. Once you start writing the equations of Newton's second law, what you will find is that the force which is being applied on the hand by the string, okay, this force comes out to be W. So the tension, which is in the string, travels upwards, and the gravity force which is experienced by this weight is felt at the hand also. So the transmission of this weight or the gravity force, is happening because of tension. So this weight is at the hand at this place because of tension. So all the forces we have written are actually tension, but we have written them at the edges, at these places. Okay. So whatever is inside the string, the forces being experienced by the string, all these are nothing but tension. Once you start writing all the Newton's second law, you will find this. And therefore, the mg force is experienced at the hand. Okay? So if you have a situation like this, this is mg. The tension will transmit this force at the topmost point wherever you're hanging it, okay? And therefore the tension is equal to mg. It's nothing but it's a something which is helping this weight be felt at the other side with the help of transmission mechanism through a massless string. You have to be very careful in understanding that the string is massless, and therefore when you write Newton's second law, everything becomes zero in those because the acceleration is zero. So when you do ma, put a is equal to 0. Thank you very much.